We're going to look at factoring these quadratics that have the a coefficient in front of the x squared. And these are particularly difficult because the regular interaction between b and c, where we multiply to b and add to c, does not work because of the way that the coefficient in front affects the value of b. So we should just make sure that we can see how there is this problem of the product C and the sum B don't work in this case when we have the numbers in front. And that ax squared comes from having a coefficient either here or both, like in this case. So when we multiply this out, we distribute this and we end up with 3 times 2. So we end up with 6x squared. So when we look at here, we're going to end up with 2x along here, 3x along here, and we end up with 6x squared. So there's our first distribution. When we distribute 3x times 3, we have plus 3 here, so we end up with 9x. So it's going to be plus 9x. When we distribute 4 times 2x, we end up with plus 8x. Okay, so this is going to be our plus 4 times 2x, gives us a plus 8x. And we have the final product here, which would be 4 times 3, which gives us a plus 12. And there's our plus 12. So these two numbers definitely are the product of the last number, okay, which is true. So we know that our final count in here is going to be based on the 12 that we started with. So I'm just going to summarize this here. So combine like terms, 6x squared plus 17x plus 12. However, the relationship between C and B are not the same. Okay, we can't multiply to 12, and we don't know how to split up that 17 because there's no products of 12 that add up to 17. It doesn't work, and we can see why, because that sum that we normally got here from here and here, that's going to be affected by the 3 here, which affects the x term here, and it's going to be affected here with the 2x. Okay, so that's going to affect this x term. So there's not that simple relationship where we add from here to here. Okay, we still have multiplying to 12, but we don't know how to split up that 17. It's difficult to see how that 17 is going to be split up. So that's very important to recognize and understand. So we should practice some of this, make sure that we can see the different parts here. So we end up with, and we can see that the complexity of the interaction. Okay, which means that when we go backwards, when we go from this expression back to these brackets, it is not as easy as a process because we can't just say times to 12 add to 17 because it doesn't work anymore. Okay, so let's take a look at this. We're going to distribute this out. So again, I'll keep color coding this. So 2x times 5x is 10x squared. So there's our 10x squared. We have our 2x times 2, which is plus 4x. Okay, 2x times 2 is our 4x down here. We have our, oops, I lost my pen, there we go. We have our negative 3 times 5x is minus 15x. So we have negative 3 times 5 is our negative 15x here, and then our final product is going to be the product of negative 3 times positive 2. And that's going to give us our negative 6 here, so minus 6. So when we combine like terms, we get 10x squared minus 11x minus 6. And again, although in the brackets the 3 and 2 do come from the 6, it is difficult to see how this 11x was generated. Okay, here it was 4 and 15. And again, the difficulty is going to be the interaction of this coefficient in front of the x and this coefficient in front of the x that generate these two terms here. So doing the last one here, first times first, it's going to give us 24x squared. Okay, that's going to give us 24x squared here. 4x times 2 plus 8x. So let's say that this is, let's make this a plus 2, so we'll make this 8x. Okay, so maybe I should write this in. So it's going to be 6x plus 2, 4x plus 1. So when we distribute the 1 out, we get plus 6x and plus 2. So that's going to be 6x plus 2. Okay, so combining like terms then, we end up with 24x squared plus 14x plus 2. So the 1 and the 2, so the 2 here, definitely this is still a product. Okay, so we know it's 1 and 2. However, the 14 here is not a simple interaction. We don't know what's going to generate that 14. It's kind of hard to see because it's not 1 plus 2. Okay, we definitely get something different in here, and that's because of this coefficient here and the coefficient here. So that's the main idea. We want to see that there is this more complex interaction. So we need a better strategy than adding to the last term, multiplying to the last term, adding to the middle. So the relationship between the coefficient on x squared and the coefficient of x in the two brackets, well, we could, that's really quite complicated. So maybe that's all we really need to know. It's complicated. Okay. So the middle, is this a simple relationship? No, this is not a simple relationship. So what strategies can we then use to factor this? If I want to now go back, multiplying out is fairly straightforward, but the problem is this 14, we don't know how to generate that 14 because it's not a simple add relationship with what we see in the trinomial here. The 2 still is, it's still a product, but this 14 is a problem because it's hard to see where that 14 came from the numbers that we start with. Okay, so what strategies can we use? Well, we're going to use that property that I showed you before. Is this diagonal product property, this 24 times 2. This is going to give us 48x squared. And along the other diagonal, 8x times 6x. Well, if we multiply those two together, 6 times 8 is 48, x times x is x squared. That diagonal product this way is equal to the diagonal product this way. Well, how's that useful to us? Well, how that's useful to us is we are now going to look for two numbers that multiply to give us this 48x squared along this diagonal, to figure out how to split up the 14x into 8 and 6, because we know that this product, this sum of 8 and 6, which gives us a 14, has to also multiply to 48. It can't multiply to something else. It has to be 48. So we couldn't do, for example, 2 times 12, which is 14 again, but 2 times 12 does not give us the 48 that we need to make this box multiplication work. So one strategy we're going to use is we're going to use the cross diagonal product to split the bx term. Okay, this is a key. How do we split up the bx? How do we split up the 14 up here if we're going to unmultiply this or factor this? Okay, so that's going to be very important. And pretty much every strategy that we have, and we're going to see something called decomposition as well, essentially uses a proper principle that we want to know how to split the middle term.